underlying the wide umbrella of alternative energy resources. Next po. Next po. When we say alternative energy resources, the first thing that obviously comes to mind is the term substitute, meaning to say it is something that if the main source depletes or gets seriously obsolete, these can take over. Alternative energy resources, by definition, refers to energy sources, all renewable sources, and nuclear other than fossil fuels. These energy resources are looked upon favorably because they do not directly emit greenhouse gases in their production. However, these two, just like other forms of energy, have their own costs, benefits, and trade-offs. Next one. The renewable energy sources stated herein are those that are produced from sources that do not deplete or can be replenished within a human's lifetime. Meanwhile, the nuclear is produced from mined elements like uranium and thorium, which cannot be replenished. Significantly, these are also those that we know and utilize at present, such as solar, wind, hydroelectric, ocean, geothermal, biomass, and hydrogen energy, which are to be discussed later. But before we head on to that, let me walk you through the milestones that alternative energy resources have achieved through the years. Next po. Next po. Next. Next po. Okay. Wait. Pakibalik po. Adeline. Next po. Okay. In 200 BC, Europeans harnessed water energy to power mills. The vertical water wheel, invented perhaps 2 centuries before the time of Christ, spread across Europe within a few hundred years. By the end of the Roman era, water wheels powered mills to crush grain, full cloth, tan leather, smelt and shape iron, saw wood, and carry out a variety of other early industrial processes. Next po. Later in the 10th century, windmills were built in Persia to grind grain and pump water. These primitive vertical carousel-type mills utilized the wind to grind corn and to raise water from streams to irrigate gardens, which soon spread to India, other parts of the Muslim world, and China. Next po. The mill reached its greatest size and its most efficient form in the hands of the Dutch engineers toward the end of the 16th century. The Dutch provinces developed the windmill to the fullest possible degree. It ground the grain produced on the rich meadows, it sawed the wood, and it ground the spices. But more than that, these windmills were also the means of raising the water of the rising streams and canals, and it also maintained the balance between the water and the land that made life possible in this precarious situation. Next po. Next. In the 1800s, English scientists William Nicholson and Sir Anthony Carlesley discovered that applying electric current to water produced hydrogen and oxygen gases. This process was later termed electrolysis. The discovery of electrolysis was an important historical step in the development of hydrogen energy and the hydrogen fuel cell that came about in 1838. Next po. William Robert Grove, a Welsh lawyer turned scientist, one renowned for his development of an improved wet cell battery in 1838. The Grove cell, as it came to be called, used a platinum electrode immersed in nitric acid and a zinc electrode in zinc sulfate to generate about 12 amperes of current at about 1.8 volts. Grove realized that by combining several sets of these electrodes in a series circuit, he might effect the decomposition of water by means of its composition. He soon accomplished this feat with a device he named a gas battery, which is the first fuel cell. Next po. Augustine Mocott, on the other hand, worried by the possibility of fossil fuels such as coal running out, develops a solar-powered steam generation system to drive industrial machinery in 1860. Mocott felt it was possible that the sun's heat could replace the burning of coal to run Europe's industries. Mocott's research into mirror technology led him to develop the first sun motor, which used the heat from concentrated sunlight to produce steam in driving machinery. Next po. Next po. In 1888, Charles F. Brush developed the world's first windmill that can generate electricity as described in an 1890 issue of Scientific American. Next po. 4 years after, Folks in Boise, Idaho built the world's first geothermal district heating system that is serving 200 homes and 40 downtown businesses. Today, there are four district heating systems in Boise that provide heat to over 5 million square feet of residential, business, and governmental space. Although no one imitated this system for some 70 years, there are now 17 district heating systems in the United States and dozens more around the world. Next po. In 1935, the Hoover Dam is completed on the Colorado River in Arizona, 4 years after construction began in 1931. At the time of its completion, the Hoover Dam was the largest hydroelectric producer in the world and remains as such until 1948. Next po. Next po. On December 20, 1951, a nuclear reactor produced useful electricity for the first time. It was barely enough to power a simple string of four 100-watt light bulbs, but the 16 scientists and engineers, all staff members of Argonne National Laboratory, which designed and built the reactor, recorded their historic achievement by chalking their names on the wall beside the generator. Next po. On the contrary, the late Dr. Hans Ziegler, probably the world's foremost expert in satellite instrumentation in the late 1950s, strongly differed with the Navy. He argued that conventional batteries would run out of power in days, silencing millions of dollars worth of electronic equipment. In contrast, solar cells could power a satellite for years. Through an unrelenting crusade led by Dr. Ziegler to get the Navy to change its mind, the Navy finally relented and as a compromise, put a dual power system of chemical batteries and silicon solar cells on the Vanguard. Just as Ziegler predicted, the batteries failed after a week or so, but the silicon solar cells kept the Vanguard communicating with Earth for years. Next po. Moving on to the 1960s, General Electric developed workable proton exchange membrane cells, aka fuel cells, for use as power supplies in the Apollo and Gemini space missions. The cells were big and very expensive, but they performed faultlessly, delivering an unwavering supply of current as well as a very useful byproduct in space, which is a drinkable fresh water. Next po. Next po. In 1978, NASA's Lewis Research Center, now NASA Glenn, dedicated a solar power system that it installed on the Papago to Nonuuudham Indian Reservation in Shushali, Aris. It was the world's first solar-powered village. The system provided power for water pumping and residential electricity to 15 homes until 1983, when the grid power reached the village. At that time, engineers hooked up the homes to the grid and the solar system began pumping water from a community well. Next po. In December 1980, U.S. Wind Power installed the world's first wind farm consisting of 20 wind turbines, rated at 30 kilowatts each on the shoulder of Crotch Mountain in southern New Hampshire. Like many firsts, it was a failure. The developer overestimated the wind resource and the turbines frequently broke. U.S. Wind Power, which later changed its name to Kenetec, subsequently developed wind farms in California and after experiencing machine failure there too, improved its designs and became the world's largest turbine manufacturer and wind farm developer before succumbing to the weight of aggressive development efforts, serious technical problems with its newest turbines, and a weak U.S. market, ultimately filing for bankruptcy in 1996. Next po. These milestones are just few of the many and continuous expanding progressions in terms of the usage and development of enhanced alternative energy resources for future use. Just like what I've said a while ago, though with this expansion, these alternative energy resources also have their own costs, benefits, and trade-offs. Next po. First on this advantage list is that fuel supply never runs out. As the name suggests, renewable energy is created from sources that naturally replenish themselves, such as sunlight, wind, water, biomass, and even geothermal or underground heat. So there really is no worry with this running out, unlike in mining of coals, oil, and natural gases, which significantly requires extensive networks of heavy machinery, processing stations, pipelines, and transportation. Second, alternative energy resources have zero carbon emissions. Perhaps the most significant benefit of renewable energy is that there are no greenhouse gases or other pollutants created during the process, whereas coal power plants create around 2.2 pounds of carbon dioxide for every kilowatt hour of electricity. Solar panels and wind turbines create none at all. As we race to decarbonize our world and embrace energy sources that don't contribute to global warming, renewables are helping to provide us with emission-free energy, heat cars, and even air travel. Next po. Third, we have a much cleaner air and water. Alternative energy resources create no pollution, waste, or contamination risk to air and water, unlike coal power stations, which release high volumes of carbon dioxide and nitrous oxide directly into the atmosphere, not only polluting the air but also contaminating waterways from air pollution that falls to the ground during rain and waste materials created during the production process. Fourth, alternative energy resources provide a cheaper form of electricity. With the rapid growth of alternative energy resources over the last 10 years, solar and wind power are now the cheapest sources of electricity in many parts of the world. In the United Arab Emirates, an area well known for its abundant land and sunny weather, a new sun farm recently secured the world's lowest price of solar energy at just 1.35 cents per kilowatt hour. The dramatic decline in solar and wind costs has even led to many fossil fuel multinationals, including the six major oil companies, to focus on renewable energy investment instead. And whereas green energy was once a clean but expensive alternative, it's now helping to reduce energy bills for people all over the world. Next po. Lastly, renewable energy creates new jobs. With an increasing focus on global warming and many governments setting ambitious carbon reduction goals, one of the surprising renewable energy advantages is that it has quickly become a major source of new job growth. In America, renewables now employ three times as many people as fossil fuels, and the Bureau of Statistics predicts that wind turbine technicians and solar panel installers will be some of the most fastest growing jobs over the next decade. And in addition to keeping millions of people in work over extended periods, many renewable energy jobs also pay above average wages. Next po. But regardless, they also have their own downsides. For one, alternative energy resources require higher capital costs. While renewable energy systems need no fuel and can deliver substantial long-term savings, their upfront costs can still be prohibitive. For example, installing a solar system on your home may cost 50,000 pesos and more, and despite your desire to power your house with renewable energy, the price tag may push it out of reach. On a larger scale, wind farms, solar parks, and hydropower stations require significant investment, land, and electrical infrastructure, resulting in some projects being delayed, altered, or even canceled. Electricity production can also be unreliable. This means that their electricity generation can be as unpredictable as the weather. Solar panels lose efficiency on cloudy days, wind turbines aren't effective in calm weather, and hydropower systems need consistent snow and rainfall to maintain reliable production. At the same time, when the renewable systems produce too much energy, they risk overloading the grid and causing major problems for network operators. Next po. Third, energy storage can be a challenge. Due to the intermittent nature of renewables, they need forms of energy storage to capture and release electricity in a consistent and controlled way. Utility scale batteries have gained significant momentum in recent years, such as the world's largest system that recently came online in California. However, despite falling costs, storage technology is still relatively expensive, and there are some lingering questions regarding its reliability and lifespan. Next po. Wait po, balik po. Fourth, it is impacted by environmental conditions. The efficiency of renewable energy systems also depends on their location and surrounding environment. For example, wind turbines are only effective in large open areas with strong and consistent wind, which limits their viability to specific regions. And while solar panels generate some electricity even on cloudy days, they are most productive in locations with consistently bright and sunny climates. In America, a solar system in Nevada is significantly more efficient than one in Minnesota, meaning that areas with fewer sunlight hours need more panels to generate the same amount of power. Next po. And at the very least, renewables and alternative energy resources still have carbon footprints. While solar panels and wind turbines produce no carbon emissions as they make energy, their manufacturing, transport, and installation still creates a carbon footprint. Renewable energy components are typically made in large factories that consume high amounts of electricity, in addition to the diesel and gasoline vehicles needed for their transport and installation. And with this growing exploration on alternative energy resources, next po. Republic Act Number 9513, an act promoting the development, utilization, and commercialization of renewable energy resources and for other purposes came in existence. Next po. Its purpose is to accelerate the development of the country's renewable energy resources by providing fiscal and non-fiscal incentives to private sector investors and equipment manufacturers or suppliers. Next po. Before we head towards the end of my report, let me leave you with this adage from Thomas Edison. I'd put my money on the sun and solar energy. What a source of power. I hope we don't have to wait until oil and coal run out before we tackle that. At the end of the day, I hope this very statement gets to us as mechanical engineers in coming up with more practical ways to harness power and energy. I guess that would be all for my part. For the thorough discussion of the different alternative energy resources, I will give the spotlight now to my other groupmates. I thank you all for listening. Again, I am Blessed Lynette Piconsina.
Good afternoon. Good evening, everyone. Today, I'm going to discuss about solar energy. Next po. What is solar energy? Next po. Solar energy is the radiation from the sun capable of producing heat, causing chemical reactions, or generating electricity. The total amount of solar energy received on Earth is vastly more than the world's current and anticipated energy requirements. If suitably harnessed, solar energy has the potential to satisfy all future energy needs. Solar power is energy from the sun that is converted into thermal or electrical energy. Solar energy is the cleanest and most abundant renewable energy source available, and the US has some of the richest solar resources in the world. Solar technologies can harness this energy for a variety of uses, including generating electricity, providing light or a comfortable interior environment, and heating water for domestic, commercial, or industrial use. In the 21st century, solar energy is expected to become increasingly attractive as a renewable energy source because of its inexhaustible supply and its non-polluting character, in stark contrast to the finite fossil fuels, coal, petroleum, and natural gas. Next. How is solar energy harnessed? There are three main ways to harness solar energy: photovoltaics, solar heating and cooling, and concentrating solar power. Photovoltaics generate electricity directly from sunlight via an electronic process and can be used to power anything from small electronics such as calculators and road sign up to homes and large commercial businesses. Solar heating and cooling or SHE and concentrating solar power or CSP applications both use the heat generated by the sun to provide space or water heating in the case of SHE system, or to run traditional electricity generating turbines in the case of CSP power plants. Photovoltaics. Photovoltaics or PV is the conversion of light into electricity using semiconducting materials that exhibit the photovoltaic effect, a phenomenon studied in physics, photochemistry, and electrochemistry. The photovoltaic effect is commercially utilized for electricity generation and as photosensors. The diagram on the right illustrates the operation of a basic photovoltaic cell, also called a solar cell. Solar cells are made of some kinds of of the same kinds of semiconductor materials such as silicon used in the microelectronics industry. For solar cells, a thin semiconductor wafer is specially treated to form an electric field, positive on one side and negative on the other. When light energy strikes the solar cell, electrons are knocked loose from the atoms in the semiconductor material. If electrical conductors are attached to the positive and negative sides, forming an electric current, the electrons can be captured in the form of an electric current, that is, electricity. Solar heating and cooling. Solar heating and cooling, or SHE, technologies collect the thermal energy from the sun and use this heat to provide hot water, space heating, cooling, and pool heating for residential, commercial, and industrial applications. These technologies displace the need to use electricity or natural gas. Solar water heating systems can be installed on most homes in the US and are comprised of three main elements: the solar collectors, insulated piping, and hot water storage tank. Electronic controls can also be included as well as a freeze protection system for colder climates. The solar collector gathers the heat from solar radiation and transfers the heat to potable water. This heated water flows out of the collector to the hot water tank and is used as necessary. Auxiliary heating can remain connected to the hot water tank for backup if necessary. Concentrating solar power. Concentrating solar power, or CSP technologies, use mirrors to concentrate or focus the sun's light energy and convert it into heat to create steam to drive a turbine that generates electrical power. CSP technology utilizes focused sunlight. CSP plants generate electric power by using mirrors to concentrate or focus the sun's energy and convert it into high temperature heat. The heat is then channeled to a conventional generator. The plants consist of two parts, one that collects solar energy and converts it to heat, and the other that converts the heat energy to electricity. Trough systems use large U-shaped parabolic reflectors focusing mirrors that have oil-filled pipes running along their center or focal point. As shown in figure 1, the mirrored reflectors are tilted toward the sun and focus sunlight on the pipes to heat the oil inside as much as 750 degrees Fahrenheit. The hot oil is then used to boil water, which makes steam to run conventional steam turbines and generators. Next, power tower systems, also called central receivers, use many large flat heliostats or mirrors to track the sun and focus its ray onto a receiver. As shown in figure 3, the receiver sits on top of a tall tower in which concentrated sunlight heats a fluid such as molten salt as hot as 1050 degrees Fahrenheit. The hot fluid can be used immediately to make steam for electricity generation or stored for later use. Molten salt retains heat efficiently, so it can be stored for days before being converted into electricity. That means electricity can be produced during periods of peak need on cloudy days or even several hours after sunset. Dish or engine systems use mirror dishes about 10 times larger than a backyard satellite dish to focus and concentrate sunlight onto a receiver. As shown in figure 5, the receiver is mounted at the focal point of the dish. To capture the maximum amount of solar energy, the dish assembly tracks the sun across the sky. The receiver is integrated into a high-efficiency or external combustion engine. The engine has thin tubes containing hydrogen or helium gas that run along the outside of the engine's four piston cylinders and open into the cylinders. As concentrated sunlight falls on the receiver, it heats the gas in the tubes to very high temperatures, which causes hot gas to expand inside the cylinders. The expanding gas drives the pistons. The pistons turn a crankshaft, which drives an electric generator. The receiver, engine, and generator comprise a single integrated assembly mounted at the focus of the mirror dish. Next po. Here is the parabolic trough system. Here is the receiver and here is the concentrators. The mirror is in a parabolic shape. And the power towers systems. Next po. And here's the figure for the dish or engine system. Pros and cons of solar energy. Cons of solar energy. Solar panels don't work for every type of roof. Rooftop solar panels are installed by connecting a mounting system, also known as racking, to your roof. Certain roofing materials used in older or historical homes, such as slate or cedar tiles, can be difficult for solar installers to work with, throwing up a roadblock for solar power. Additionally, many homes and apartment buildings have skylights or other rooftop additions like roof decks that can make the solar installation process difficult or costly. Solar isn't ideal if you're about to move. Solar is a great financial investment, but it can take some time to reach the break-even point so often heralded by industry sale reps. The average solar panel payback period in the US is around 7.5 years. For a young homeowner who may be moving in coming years, putting solar panels on his or her roof might feel like an unworthy investment. Next po. If your electricity costs are low, so are your solar savings. The ultimate benefit of solar energy is that it will reduce your use of utility provided electricity and save you money every month as a result. However, that condition assumes a homeowner has sizable electric bills to begin with. For a homeowner in a state like Louisiana, where the cost of electricity is 25+% lower than the national average, installing a solar panel system isn't really nearly as attractive as it is to a white homeowner who pays more than double the average electric rate. If you can't access sol- if you can't access solar financing, upfront solar costs can be intimidating. There's a nationwide debate going on about how much homeowners have to pay out of pocket for solar. The total out of pocket price tag for a solar panel system depends on tax credits, rebates, and financing option you choose. Though you can easily get a figure for the average cost of solar in your state or even a personalized estimate of your home, the simple answer is that the upfront cost of solar is sizable if you don't qualify for a zero down solar loan. Finding quality local solar installers and easily comparing quotes can be difficult. There's a common association that many homeowners have with solar. It has to do with pushy door-to-door solar sales reps that pressure consumers to sign a 20-year solar contract before they explain the full scope of the offer or the credibility of the solar company. Solar is one of the fastest growing markets in the world, and there are plenty of companies that are deploying aggressive sale tactics to get their fair share of the market. As a result, for many people, shopping for solar can be a stressful and confusing scenario. Pros of solar energy. Solar can drastically reduce or eliminate your electric bills. This top benefit of solar panels is pretty straightforward. When you install solar power for your home, you generate your own electricity, become less reliant on your electric utility, and reduce your monthly electric bill. A solar panel system typically has a 25 to 35-year lifespan, which means that you can cut your electricity costs for decades to come by going solar. Solar improves the value of your home. Millions of US homeowners are interested in solar panels but haven't taken the time to figure out what it takes to install them. This consumer reality and the undeniable benefits of having solar panels on a home complements recent studies that found property values increase after solar is installed. Thus, the second pro of solar can help to level out one of the cons that we discussed earlier. Even if you're planning on moving in the near future, you'll earn back your solar panel investment and then some when you sell your home. Next one. Solar reduces carbon emissions. Solar is a clean, renewable source of energy that can help reduce carbon dioxide emissions and lower our impact on the natural environment. Unlike traditional fossil fuels like coal and oil, solar energy does not lead directly to pollutants like carbon dioxide being released into the atmosphere and water supply. Even compared to nuclear energy, solar comes out on top in terms of being a more environmentally friendly solution. Going solar gives you control over rising energy costs. Many homeowners face anxiety when it comes to their electricity bills because, in most scenarios, there is nothing you can do to control your utility electricity rate. While the cost of solar has decreased by more than 70% in the past decade, the cost of electricity has risen by about 5%, and that trend in rising electric cost is expected to continue. Going solar puts you in the driver's seat when it comes to energy generation. Solar can pay you money while you're earning back your investment. Due to a number of awesome solar incentives in the US, solar panels can actually turn you a profit in addition to generating bill savings that pay off the cost of the system. Solar renewable energy credits or SRECs and net metering are two key advantages of solar energy that allow you to earn bill credits or even extra cash. As your system produces electricity, in these scenarios, you are being compensated for the electricity that your solar panels generate.
Good evening, everyone. This is Charlotte Luces, and I will be the one to discuss one of the alternative energy resources, which is the wind energy. So first, let me discuss to you the definition of wind as well as wind energy or wind power. Wind is a form of solar energy caused by a combination of three concurrent events: the sun unevenly heating the atmosphere, irregularities of the Earth's surface, and the rotation of the Earth. The wind is also a clean, free, and readily available renewable energy source. Wind energy or wind power describes the process by which wind is used to generate electricity. Wind turbines convert the kinetic energy in the wind into mechanical power, and the generator can convert that mechanical power into electricity. The research of wind energy dates back several decades to the 1970s when NASA developed an analytical model to predict wind turbine power generation during high winds. Today, many countries have implemented them. The Philippines is actually one of the largest wind power generators in the ASEAN region. Later on, I will provide some of the examples of wind energy found here in the Philippines. So wind power plants have been set up in locations where the wind velocity is high. These areas receive less rainfall compared to the other parts of the country. Rainfall accompanied by wind in these areas will not affect electricity generation. However, in the event these areas experience heavy rain continuously, power generation will decline. There will be a steady drop in electricity generation. Next po. We have the two types of wind energy. Next. First is the horizontal axis turbine. This is what many people picture when thinking of wind turbines. Most commonly, they have three blades and operate upwind, with the turbine pivoting at the top of the tower so the blades face into the wind. Horizontal axis turbines also produce more electricity and for this reason are used far more than their vertical counterparts. Next is the vertical axis turbines, which come in several varieties including the egg beater style Darius model named after its French inventor Georges Darius. These turbines are omnidirectional, meaning they don't need to be adjusted to point into the wind to operate. Next, wind energy process. Next. So how does a wind turbine work? At the right side of your screen, you can see an animation how a wind turbine works as well as its parts or components. So a wind turbine turns wind energy into electricity using the aerodynamic force from the rotor blades, which work like an airplane wing or helicopter rotor blade. When wind flows across the blade, the air pressure on one side of the blade decreases. The difference in air pressure across the two sides of the blade creates both lift and drag. The force of the lift is stronger than the drag and this causes the rotor to spin. The rotor connects to the generator either directly or through a shaft and a series of gears that speed up the rotation and allow for a physically smaller generator. This translation of aerodynamic force to rotation of a generator creates electricity. How does a wind plant work? Again, at the right side of your screen is an animation how wind power plants produce electricity and how it powers our homes or communities. So wind power plants produce electricity by having an array of wind turbines in the same location. The placement of a wind power plant is impacted by factors such as wind conditions, the surrounding terrain, access to electric transmission, and other siting considerations. In a utility-scale wind plant, each turbine generates electricity, which runs to a substation where it then transfers to the grid and where it powers our communities. Sizes and application of wind turbines. First, we have the land-based wind, which range in the size from 100 kilowatts to as large as several megawatts. Larger wind turbines are more most cost-effective and are grouped together into wind plants, which provide bulk power to the electrical grid. Next is the offshore wind. The offshore wind turbine tends to be massive and taller than the Statue of Liberty. These turbines are able to capture powerful ocean winds and generate vast amounts of energy. Then distributed wind. When wind turbines of any size are installed on the customer side of the electric meter or are installed at or near the place where the energy they produce will be used, they are called distributed wind. Many turbines used in distributed applications are small wind turbines. Single small wind turbines that are below 100 kilowatts, which are typically used for residential, agricultural, and small commercial and industrial applications. Next po. Wind energy pros and cons. First, we have the pros. So first, wind energy is a free source of energy. Since wind turbines themselves run strictly on the power of wind generated, it doesn't need to be fueled or connected to power to continue working. Next is that it is clean and renewable. Unlike coal, natural gas, or oil, generating electricity from wind doesn't result in greenhouse emissions. Additionally, wind energy is completely renewable and will never run out. Next is that it has low operating costs. Wind farms or individual turbines can be expensive to install. However, once up and running, operating costs are relatively low. Their fuel or the wind is free and the turbines don't require too much maintenance. The next is that wind energy is space efficient. Cumulatively, wind farms can take up a lot of land space. However, the actual turbines and equipment don't use up a lot of real estate. This means that land used for wind turbines can often also be used for other purposes, such as farming. Cons. Wind energy is intermittent. A wind turbine's effectiveness in generating electricity depends on the weather. Thus, it can be difficult to predict exactly how much electricity a wind turbine will generate over time. Next is that wind turbines have some negative impacts on their surrounding environment. The blades can harm and kill species that fly into them, like birds and bats. The construction of wind farms can also disrupt natural habitats of local species if not conducted in a sustainable manner. However, these problems can be solved to some extent with technological advancements and properly siting wind farms. Then lastly, wind energy causes noise and visual pollution. Wind turbines can be noisy when operating, as a result of both the mechanical operation and the wind vortex that's created when the blades are rotating. Furthermore, because wind turbines must be constructed high enough to capture a significant quantity of wind, they sometimes disrupt otherwise scenic landscapes such as mountain ranges, oceans, and more. Next one. Wind power in the Philippines. As demand for energy is rising, wind turbines are helping the Philippines diversify its energy sources beyond fossil fuels and generating power. The Philippines has significant wind energy resources spread across various islands of the country. So these are just some of the examples of wind energy in the Philippines, but actually there's a lot more. So first is the Bangui Wind Farm in Ilocos Norte. At the northwest tip of Luzon Island is the country's oldest wind farm and the first power-generating wind farm in the Southeast Asia. Operated by the North Wind Power Development Corporation, Bangui Wind Farm was born out of study done in 1996, and its commercial operation started in 2005. Next is the Burgos Wind Farm in Ilocos Norte. The 150 megawatts Burgos Wind Farm is currently the largest wind farm in the country and in Southeast Asia, with 50 wind turbines covering 600 hectares and 3 barangays of Burgos. It was completed in November 2014. Caparispi Wind Farm in Ilocos Norte. The 81 megawatts Caparispi Wind Energy, which was developed by the Northern Luzon Renewable Energy Corporation, was formally inaugurated on November 19, 2014. It has 27 units of wind turbines installed atop the hill in the 625-hectare land area. Next is the Pililia Wind Farm in Rizal. It was commissioned in June 2015. The 54 megawatt Pililia Wind Farm consists of 27 wind turbines that stretches 125 meters in height, strategically situated on the lush hills with strong winds in Pililia, Philippines, capable of producing more than 132,000 megawatts that can meet the electricity needs of approximately 66,000 local households. San Lorenzo Wind Farm in Guimaras. A pioneering renewable energy project in the Visayas region, the 54 megawatts Guimaras Wind Farm generates over 120 gigawatt hours of electricity annually, which can sustain the energy demand of over 48,000 households. It was developed to hit the higher energy demand in the province due to the surge in infrastructure and economic progress. Next is the Nabas Wind Farm in Aklan. The Nabas Wind Power Project provides a source of renewable energy to the Visayas grid, which includes the over 90 households in the far-flung barangay of Pawa in Nabas Aklan. And lastly, the Puerto Galera Wind Farm in Mindoro. The wind power energy system in Puerto Galera is a 48 megawatts wind power project operated by the Philippines Hybrid Energy System Incorporated, and its first stage of development was approved in June 2011 by Department of Energy, and this was completed at the end of the second quarter of 2019, and its commercial operations commenced in the third quarter of the same year.
Good day, everybody. I am Maria Ivy Bernadette Surita, and I'm going to talk about ocean energy. Next po. So, ocean energy. Ocean cover most of the 70% of the Earth's surface, and they generate thermal energy from the sun and produce mechanical energy from the tides and waves. The solar energy that is stored in the upper layers of the tropical ocean, if harnessed, can provide electricity in large enough quantities to make it a viable energy source. The oceans have proved to be a promising source of energy. It is a renewable source of energy. However, it is still not popular as compared to other non-conventional sources of energy like solar energy. We have scientists working on the development of ocean energy and its application. Considering the amount of ocean energy produced in today's world, it is almost negligible compared to the global scales. Next po. Global potential. So there is a potential to develop 20,000 to 80,000 terawatt hours of electricity generated by changes in ocean temperatures, salt content, movement of tides, currents, waves, and swells. The country's ocean resource area consists of 1,000 square kilometers, attributed mainly to its archipelagic nature. Based on a study conducted by the Mindanao State University, the potential theoretical capacity for this resource is estimated to be about 170,000 megawatts.
Although there is little available information on the potential of ocean energy, navigational experiences hypothesize that these systems present significant resource options. The initial ocean energy potential sites identified in the Philippines include the Hinatuan Passage, Camarines, northeastern Samar, Surigao, Batan Island, Catanduanes, Tacloban, Bernardino Strait, Babuyan Island, Ilocos Norte, Siargao Island, and Davao Oriental. So according to the Department of Energy of our country, roughly 76% of the Philippine sources of energy came from fossil fuels, and the remaining percent was mainly attributable to the renewable. So the ocean energy is still not part of the current energy mix. Next po. So there are different types of ocean energy. We have wave energy, tidal energy, salinity gradient energy, and ocean thermal energy conversion. Next po. Wave energy. It captures the energy contained in ocean waves and uses it to generate electricity. Converters include oscillating water columns that trap air packets to drive a turbine, oscillating body converters that use wave motion, and overtopping converters that make use of height differences. Regular disturbances on the surface of the water are called waves. The wave energy is a form of kinetic energy. This is used to power a turbine. Wave energy is captured from the surface of the waves produced in the oceans. A turbine is chosen for a hydroelectric power station and is decided primarily by the water conditions. However, the main issue with the ocean wave energy is that it needs a costly setup. Also, water conditions are not the same in every part of the world. Even on the coastal areas, the waves are not the same always. Along with the waves, we also need to have high force of air to regulate the turbines. Next po. Next is tidal energy, produced either by a tidal range technologies using a barrage or a dam or other barrier to harvest power between high and low tide, tidal current or tidal stream technologies, or hybrid applications. Tidal energy is formed from the movement of water currents and is known for a longer time than wave energy. It is another form of hydropower and uses rise and fall of tides to generate electricity. Since tides are much predictable than waves, it is a better option than wave energy. The other reason is that due to massive size of the oceans, its potential of producing energy can't be ignored. So the tidal energy is not that popular, but it's taking the world by storm. So the biggest tidal power station in the world is in France, and it produces about 240 megawatts of power annually and has capacity to power 240,000 homes. Next po. There are two types of tidal energy. First one is the potential energy. The potential energy of sea level differences associated with the tides. Dams close off sea basins at flood or high tide and low head turbines through which the trapped water is released at low tide. The next one is the kinetic energy of tidal currents. Water mills submerged in the tidal streams and tidal stream turbines. Next po. Next is the salinity gradient energy, arose from differing salt concentrations as occurs where a river empties into an ocean. Demonstration projects Demonstration projects use pressure retarded osmosis with fresh water flowing through a membrane to increase the pressure in a tank of salt water and reverse electrodialysis with ions of salt passing through alternating tanks of salt and fresh water. Next po. The last one is the ocean thermal energy conversion. The ocean thermal energy conversion, which generates power from the temperature difference between warm surface seawater and cold seawater at 800 to 1000 meters depth. The water gets too cold as you deep dive into the ocean. The more difference in temperature, the bigger will be the efficiency of this method. So this concept was first introduced by French engineer Jacques d'Arsonval back in the year 1881, and some thought it could become the most profitable way of producing energy through conventional energy sources. So there are three types of Ottec energy system. The first one is closed cycle. Closed cycle systems are used or system use warm water on the ocean surface to vaporize a fluid that has a low boiling point called ammonia to turn a turbine which activates a generator to generate electricity. The second one is open cycle. Open cycle systems use the ocean's warm surface water by placing it in a low pressure container. This boils the water and it starts producing steam. The steam is then passed through turbines, which in turn are attached to an electrical generator. The last one is the hybrid systems. Hybrid systems uses positive features of both closed cycle and open cycle systems. The warm water on the sea surface is pumped through a heat exchanger into a vacuum chamber. Next po. So the devices that convert water energy. First one is floats or pitching devices. Generate electricity from the bobbing or pitching action of a floating object that is mounted to a floating raft or to a device fixed on the ocean floor. Second one is oscillating water columns. Generate electricity from the rising and falling of water column in a cylindrical shaft that drives air into and out of the top of the shaft, powering an air-driven turbine that turns continuously in one direction. Third one is wave surge or focusing devices. Shoreline devices called tapered channel or tap-chan systems that concentrate the waves, driving them into an elevated reservoir where their potential energy is used to generate electricity using standard hydropower technologies like the dam. Next po. Environmental impacts of ocean energy. The first one is artificial habitats. Devices could attract and promote population of various marine creatures. The second one is noise. Comes primarily from the wells turbines of shoreline OWC so it needs to be soundproof. Next one is navigation hazards. Adequate visual and radar warning devices can be built into most devices to warn marine traffic. Next one is visual effects. View of shoreline could be affected. Leisure amenity. Devices could provide calm waters when used as breakwaters, thereby promoting some water sports like canoeing and scuba diving. Conversion and transmission of energy. There may be visual and environmental impacts associated with the transmission line to shore grid. Lastly is emissions. No emissions of carbon dioxide, sulfur dioxide, and nitrogen oxide and particulates during operation, but some during construction. Next po. The benefits of ocean and tidal energy. Electrical power generation from ocean and tidal energy will utilize renewable energy and extend the lifetime of our finite fossil fuels. Next one is the generation of power is clean, does not emit pollutants like SO2, NOx, and particulates, and reduces emissions of carbon dioxide, thus avoiding global warming. Ocean wave and tidal power structures can be incorporated into harbor walls, breakwater, coastal protection of reclaimed land, and highways. Isolated island communities could be provided with renewable power as well as potable water through cogeneration of power and fresh water. Power can be used to electrolyze water for stored production of hydrogen as fuel for advanced CHP or combined heat and power, fuel cells, and etc. In combination with fresh and seawater hydro schemes, marine generation with pump storage can supply peak demand. Lastly, produce ice and preserve and add value to artesian fisheries. The risk from ocean and tidal energy. The main risk in the ocean and tidal power development pertains to the actual construction of the plant. Barrage or dam construction techniques in deep estuaries are less well understood. Like conventional hydro projects, a tidal power plant will be subject to geological risk associated with the nature of rock foundations at the project site. Financial risk, currency fluctuations, and security of power purchase agreements are obvious areas of concern. And lastly is the Financial risk of costly and lengthy overruns is the most critical risk because it is capital intensive and sensitive to prevailing discount rate. And that's for the references. That's all for the ocean energy. I'm giving the floor to Miss Mikey Buen to discuss about geothermal energy.
So good afternoon, everyone. I am here to discuss about the geothermal energy. So next. So what is geothermal energy? Next. So the word geothermal comes from the Greek words geo, which means earth, and therm, which means heat. Geothermal energy is a heat within the earth. It comes from heat generated during the original formation of the planet and the radioactive decay of materials. It is contained in the rocks and fluids beneath the Earth's crust and can be found as far down to the Earth's molten rock or magma. Next. So, geothermal energy finds its way to the Earth's surface in three ways. First is the volcanoes and fumaroles. Next is hot springs, and third is the glaciers. These underground reservoirs of steam and hot water can be tapped to generate electricity or heat and cool buildings directly. These geothermal reservoirs are naturally occurring areas of hydrothermal resources. First is the volcanoes and fumaroles are holes in the earth where volcanic gases are released. And hot springs can also be, or also called thermal spring, are springs with water at temperatures substantially higher than the air temperature of the surrounding region. And most hot springs discharge groundwater that is heated by shallow intrusions of magma in volcanic areas. The glacier is a rare kind of and erupts, which sends jets of water and steam into the air. Glaciers are made from a tube-like hole in the Earth's surface that runs deep into the crust. So these geothermal reservoirs are located near the boundaries of the Earth's tectonic plate. Next po. So to produce power from geothermal energy, wells are dug a mile deep into underground reservoirs to access the steam and hot water there, which can then be used to drive turbines connected to electricity generators. Next po. So there are three main types of geothermal energy systems. First is the direct use, second is geothermal heat pumps, and the third is the geothermal power plants. Next po. So direct use and district heating systems use hot water from springs or reservoirs located near the surface of the earth. All direct use applications make use of low temperature geothermal resources which range between 50 and 150 degrees Celsius. And hot water is often used directly in the heating system, or it may be used in conjunction with a heat exchanger which transfers heat when there are problematic minerals and gases such as hydrogen sulfide mixed in the fluid. So the image shows the Bagno Vignoni hot spring in Italy. Next po. Next is the geothermal heat pumps. Geothermal heat pumps take advantage of the relatively stable, moderate temperature conditions that occur within the first 300 meters of the surface to Earth to heat buildings in the winter and cool them in the summer. In that part of the lithosphere, rocks and groundwater occur at temperatures between 5 and 30 degrees Celsius. At shallower depths where most GHPs are found, such as within 6 meters of the Earth's surface, the temperature of the ground maintains a near constant temperature of 10 to 16 degrees Celsius. Next po. So this is an example of a residential heat pump. A GHP system is made up of a heat exchanger, a loop of pipes buried in the ground, and a pump. So the heat exchanger, the heat exchanger transfers heat energy between the ground and air at the surface by means of a fluid that circulates through the pipes. The fluid used is often water or a combination of water and antifreeze. So during warmer months, heat from the warmer air is transferred to heat exchanger and into the fluid. As it moves up through the pipes, the heat is dispersed to the rocks, soil, and groundwater. The pump is reversed during the colder months, and the heat energy stored in the relatively warm ground raises the temperatures of the fluid. So the fluid then transfers this energy to the heat pump, which warms the air inside the building. Next po. The third is the geothermal power plants. So geothermal power plants uses energy from the Earth's internal thermal energy to produce electricity. Geothermal power plants use hydrothermal resources that have both water and heat. Geothermal power plants require high temperature hydrothermal resources that comes from either dry steam wells or from hot water wells. People use these resources by drilling into the earth and then piping steam or hot water to the surface. The hot water or steam powers a turbine that generates electricity, and some geothermal wells are as much as 2 miles deep. Next po. So geothermal power plants come in 3 different designs. First is the dry steam, the flash steam, and the binary cycle. Next po. So the dry steam geothermal power generation simply collects rising steam from the ground and use hydrothermal fluids that are primarily steam. So the steam travels directly to a turbine, which drives a generator that produces electricity. The steam eliminates the need to burn fossil fuels to run the turbine. And these plants emit only excess steam and very minor amount of gases. Next po. So flash steam geothermal power generation are the most common type of geothermal power generation plants in operation today. Fluids at temperature greater than 300 degrees Fahrenheit is pumped under high pressure into a tank at the surface called flash tanks, held at a much lower pressure, causing some of the fluid to flash or rapidly vaporize into steam. The steam is then used to power the turbine generator set. So if any liquid remains in the second tank to extract even more energy. Next po. So the binary cycle geothermal power generation. Binary cycle power plants use steam driven of a secondary working fluid such as ammonia and hydrocarbons contained within a closed loop of pipes to power the turbine generator set. So in this process, transferred to the working fluid through a heat exchanger. The working fluid then vaporizes, and after the vapor from the working fluid passes through the turbine, it is recondensed and piped back to the heat exchanger. Next po. So the geothermal energy pros and cons. Next po. The main advantage are that it's not depending on weather condition and has a very high capacity factors. For these reasons, geothermal power plants are capable of supplying baseload electricity as well as providing ancillary services for short and long-term flexibility in some cases. Second is, it is a carbon-free, renewable, sustainable form of energy that provides a continuous, uninterrupted supply of heat that can be used to heat homes and office buildings and to generate electricity. Third is, geothermal energy only produces 1/6 of the carbon dioxide produced by a natural gas plant and is not an intermittent source of energy like wind or solar. Its potential production could reach at least 35 gigawatts and as high as 2 terawatts. Next, geothermal is also cheaper than conventional energy, with savings of as much as 80% compared with fossil fuels, and unlike other renewable energy sources such as solar wind, it is constantly available. Next po. So the cons. Production is limited to areas near tectonic plate boundaries, and in addition, some locations may cool down after decades of use. Second is geothermal heat coming from the reservoir below may die down or run out of steam even after years of activity. Most research studies suggest that geothermal reservoirs are permanent, but some studies indicate that they can be depleted if the water is extracted faster than it can replenish itself. And although it is cheaper than fossil fuels, once a plant has been built, the drilling and exploration of these sites is expensive. This is in part due to the amount of wear experienced by drills and other tools in such aggressive environments. Geothermal power plants have been cause of mini tremors in the area, and despite low carbon dioxide production, geothermal has been associated with other emissions like sulfur dioxide and hydrogen sulfide. Next po. So geothermal Philippines. So since the Philippines is located within the Pacific Ring of Fire, this implies that it is prone to intensive volcanic activity and earthquakes. There are 53 active volcanoes in the Philippines, and the Philippines is the world's second largest producer of geothermal energy for power generation. In fact, it is home to 3 of the top 10 biggest geothermal power plants in the world. Next po. So, exploration of geothermal energy in the country started somewhere in 1950s under the helm of Professor Arturo Alcaraz, who headed the Commission of Volcanology. The commission studied and made an inventory through geological mapping and surveys. The Commission on Volcanology laid the foundation for the commercial utilization of geothermal energy between 1952 to late 1960s when it studied and inventoried with geothermal activity at the number of localities. So the image shows the historic lighting of several electric bulbs on April 12 of 1967 in Barrio Calais in Tiwi, Albay. The service contract system signed in 1971 between the National Power Corporation and the Union Oil of California for the development of Tiwi and Bacban. Next po. So the image shows that in July 1977, the first commercial geothermal power generation in the Philippines commenced at TNOC's 3-megawatt power plant in Palintinon. Next po. So the Leyte geothermal production field. So the Leyte geothermal production field comprises of 6 geographic sectors, namely Mahiyaw, Sambaloran, Malitbog, Mamban, Mahanagdong, and Bao Valley. And they have 2 independent hydrothermal systems called the Tongonan geothermal field in the north and the Mahanagdong geothermal field. So the image shows the geological mapping of the Leyte geothermal production field. Next po. The Tongonan Geothermal Power Plant. The Tongonan Geothermal Power Plant is the largest geothermal installation in the Philippines. It is located in Cananga, Leyte, and has a capacity of 722.68 megawatts electric, or 37% of the total installed geothermal capacity. Next po. The Tiwi Geothermal Power Plant. In 1982, Tiwi became the first water-dominated geothermal system to produce more than 160 megawatts electric. But due to the aging power of the power plant stations, the capacity of the field was derated from 330 megawatts to 275 megawatts. Next po. The Makiling Banahaw or Macban Geothermal Reservoir. The Macban is also called Bulalo Reservoir. It is a liquid-dominated, fractured-control geothermal system. The hydrothermal system developed at Bulalo is associated with 2 dactic domes, which is the Mount Bulalo and the Mount Ulila, present on the southeast flank of Mount Makiling. Bulalo is the second largest geothermal facility in the Philippines. Next po. The Palimpinon Geothermal Field. The Palimpinon Geothermal Power Plant consists of two power stations. The Palimpinon 1, which is with an installed capacity of 112.5 megawatts electric and is operational since 1993. Next is the Palimpinon 2, which has three modular plants, namely 20 megawatts electric Okoy, the 20 megawatts Nasuji, and the 40 megawatts Sogongon. Next po. The Bacon Maanito Geothermal Power Plant. So, the Bacon Maanito Geothermal Power Plant has three generating power plants. The Bacman 1, Bacman 1 or the Palayang Bayan, and the Bacman 2, Kawayan and Boto. The first unit of the 110 megawatts electric Palayang Bayan Power Plant and the 20 megawatts electric Kawayan and the 20 megawatts electric Botong Power Plant. Next po. The Mindanao Geothermal Production Field. It is also known the Mount Apo Geothermal Power Plant, and it is made up of two power plants. The Mindanao 1, which is commissioned in 1996 with a capacity of 52 megawatts electric, and the Mindanao 2, which is put online in 1999 with an installed capacity of 54.24 megawatts electric. That's all.
Good evening po. So, I am Vincent Cuera and I am here to discuss or to give some ideas on biomass energy. Next po. So, biomass is also known as bioenergy. It is an energy produced from organic matter. It is also an organic made of material that comes from living organisms such as plants and animals. Next po. So, these are the sources of biomass energy: agricultural crops and residues, sewage or human manure, municipal solid waste, animal residues, industrial residues, forestry crops and residues. So, these are also called po as feedstock. Next po. So, there are three primary ways or methods of converting biomass into energy. First po is combustion. The second po is bacterial decomposition or anaerobic digestion. And the third one is the conversion to a gas or liquid fuel. Next po. So combustion is most electricity generated from biomass is produced by direct combustion. Biomass is burned in a boiler to produce high pressure steam. This steam flows over a series of turbine blades, causing them to rotate. The rotation of the turbine drives a generator producing electricity. Next po. So this po is a simple diagram showing the combustion process. So the steam turbines will power up a generator producing po electricity. Next po. So the second process po is the bacterial decomposition or anaerobic digestion. Organic waste material such as animal dung or human sewage is collected in an oxygen-free tank called digester. Here, the material is decomposed by anaerobic bacteria that produce methane and other byproducts to form a renewable natural gas, which can be then purified and used to generate electricity. Next po. So, common biomass po na kinokollect or dinadan po during bacterial decomposition are human manure po and animal waste. So, nilalagay po sila sa anaerobic digester that produce biogas and digestate. Yung digestate po is common, ginagamit po siya sa mga fertilizer. And the biogas, which we converted as biomethane that will power up the generator that produce electricity, and some are fuels po. Next po. So the third one po is the conversion to a gas or liquid fuel. Biomass can be converted to a gaseous or liquid fuel through gasification and pyrolysis. Gasification is a process that exposes solid biomass material to a high temperatures with a very little oxygen present to produce synthesis gas or syngas, a mixture that consists mostly of carbon monoxide and hydrogen. The gas can be then burned in a conventional boiler to produce electricity. It can be also used to replace natural combined cycle gas turbine. So, gasification process converts solid fuel into gaseous fuel through process of high temperature oxidation reduction reaction po. Meanwhile, combustion process converts solid fuel into gaseous product of combustion through high temperature oxidation reaction. Next po. So pyrolysis uses a similar process to gasification but under different operating condition. In this scenario, biomass is heated at a lower temperature range but in the complete absence of oxygen to produce a crude oil to produce a crude bio oil. This bio oil is then substituted for fuel oil or diesel in furnaces, turbines, engines, and electricity production. Next po. So this po is a gasification diagram. Almost similar po siya sa combustion pero iba po yung ano. Instead po of boiler, it uses po gasifier. Next po. This po naman is the diagram for pyrolysis. Next po. So what are the advantages and disadvantages of biomass? Next po. So it provides a relatively cheap fuel source, reduces reliance on fossil fuels, and provides self-sufficiency even during blackouts. Next po. So the disadvantages are fuel quality or consistency can vary significantly, produces more indoor and outdoor air pollution than conventional heating fuels, even with the use of advanced combustion technology, creates the risk of fire and carbon monoxide poisoning, can require cutting woods as well as the skill to lay fires, requires regular tending and maintenance, and lastly, fuel storage requires a lot of space. Next po. So where can we find biomass in the Philippines? So agriculture crops residues, forest residues, animal waste, agro-industrial waste, municipal solid waste, and aquatic biomass are abundant in the Philippines. Rice husk, sugarcane, coconut shell or husk are the most common agricultural waste. Next po. So these are the known biomass power plant in the Philippines. So Asea Gas Corporation in Lian, Batangas produces 8.8 megawatts. The second is San Carlos Biopower in San Carlos, Negros Occidental that produces 19.9 megawatts. The Isabela Biomass Energy Corporation in Alicia, Isabela produces 18 megawatts. And the Isaiah One Power in Aklan, Panay that produces 42 megawatts. Next po. So that ends up po my topic in biomass. Thank you po.
Hello po, rinig na po ba? Ayan, pamanin po kung may mga sounds tayo dito. Ayan. So, good evening everyone. I am Adeline Joy Ariales, the last presenter of our group finally. I will discuss the basics of hydrogen energy. First, what is hydrogen energy? Hydrogen energy, as you can see, involves the use of hydrogen and or hydrogen containing compounds to generate energy to be supplied to all practical uses needed with high energy efficiency, overwhelming environmental and social benefits, as well as economic competitiveness. Simply put, hydrogen energy is another alternative energy source that uses hydrogen and or hydrogen containing compounds. This leads us to another discussion topic: how to produce hydrogen energy. Even though hydrogen is a colorless gas, there are different colors of hydrogen that denote how it is produced. Brown hydrogen uses lignite or brown coal in the hydrogen making process. Gray hydrogen is created from natural gas or methane using steam methane reformation. Blue hydrogen is produced mainly from natural gas but with carbon capture and storage. Green hydrogen uses renewable energy sources to electrolyze water. When you search the internet, you will find a couple more colors that signify other production methods. But these four colors are the most common colors of hydrogen that we will discuss in detail starting now. Brown hydrogen transforms coal into gas via gasification. According on the previous slide, the brown color is from the brown coal used to produce hydrogen. Like what Vincent has said, gasification uses a tiny amount of oxygen which is then combined into steam and cooked under intense pressure. It is different from combustion as combustion only uses oxidation reactions to convert solid fuel to gas, whereas gasification, the one that is being used to produce brown hydrogen, converts solid to gas via oxidation reduction or redox reactions. The gas generated via coal gasification is called syngas, short for synthetic gas. The hydrogen from syngas can be separated from other elements using adsorbers or special membranes. The process of reproducing brown hydrogen produces three main products: hydrogen, the desired product, and carbon monoxide and carbon dioxide that are being released into the atmosphere. Another similar variant of brown hydrogen is black hydrogen. Black hydrogen is being produced through the same process but uses black coal. Looking at the process diagram presented, we can see that producing black and brown hydrogen are the most detrimental processes to the environment because these processes emit the highest greenhouse gases as compared to all other colors of hydrogen. Let's move on to gray hydrogen. Gray hydrogen comes from natural gas, where hydrogen is bonded with carbon. This hydrogen is separated via steam reforming, a process involving water. Aside from the separated hydrogen, it generates carbon dioxide that is being released into the atmosphere. Gray hydrogen is the most commonly produced hydrogen that accounts from roughly 95% of the hydrogen produced in the world today. It is because it is the most efficient process, unlike all the others. Even if it is more safer than as compared to black or brown hydrogen, given its scale, it is still harmful to the environment as more greenhouse gases are being emitted. Third color is the blue hydrogen. Blue hydrogen has a somewhat similar process with gray hydrogen because it uses the same material, natural gas, and steam reformation is also used. What makes it different is that carbon dioxide is being captured and stored, what we call carbon capture and storage or CCS. As you can see in the picture, the main difference of blue hydrogen to gray hydrogen is its CCS. Once the carbon dioxide is captured, it is compressed into a fluid and transported into an appropriate storage site. It is then injected into deep underground geological formations where it is stored long term. Storage sites used for carbon dioxide include former oil and gas reservoirs, deep saline formations, and coal beds. Green hydrogen is the last color that we will discuss. I would have skipped everything earlier and moved all the way to this topic, but I would like to present all other main processes of producing hydrogen first to prove a better point on why this type of hydrogen is considered as green. It is made through a process known as electrolysis. If you have forgotten the meaning of electrolysis, it is a process where an electrolyzer splits a compound into its constituent elements using an electric current. Most often, this compound is water, divided into hydrogen and oxygen. If electricity used comes from renewable sources, the hydrogen produced is known as green hydrogen. This diagram shows how electricity produced from renewable sources like solar and wind energy are being used to power the electrolyzer. The electrolyzer then separates the water molecules into hydrogen and oxygen atoms. Oxygen ions, I mean. The separated hydrogen and oxygen ions are unstable because of their electron configurations, but they will be contained. If companies need only the hydrogen, they will compress it and deliver it already. If the aim is to produce electricity, hydrogen and oxygen atoms undergo a chemical reaction to produce water, heat, and electricity. This proves that throughout the production, the process is green because the emissions are significantly smaller as compared to previously mentioned hydrogen colors. Another question to be answered in this discussion would be, what are the pros of hydrogen energy? The advantages to be discussed here are those from the green hydrogen. First is low to zero emissions. This has been mentioned earlier. Second, high efficiency. Fuel cell vehicles are one application of hydrogen energy. Because of its efficiency, a hydrogen fuel cell is 2 to 3 times more efficient than an internal combustion engine fueled by gas. And the fuel cell electric vehicle's refueling time averages less than 4 minutes. Third, versatile. Like what I have said earlier, hydrogen energy can be used to power fuel cell vehicles and also to power different industries as it can also be converted to electricity. With all the rockety designs of my PowerPoint presentation, did you know that NASA uses hydrogen as rocket fuel to deliver crew to space? Fourth, scalable. It can still grow larger as the demand for more green sources of energy increases. Fifth, reliable. Aside from its energy capacity, hydrogen is the most abundant element on the planet. Given the most efficient means to harvest green hydrogen, there is a fair chance that we will have a shortage of energy. Sixth is durable. Given the demands of processing and storage of unstable hydrogen, the materials used must meet such demands, making them durable. Last is quiet operation. With sources like solar, wind, and hydro energy, it will not produce much noise, especially noise caused by carbon dioxide emissions. After discussing the pros of hydrogen energy, we will now discuss its cons. First, difficult to store and transport. Hydrogen, as we all know, is unstable, so it must be compressed into extremely cold temperatures to liquefy and store it. Second is fuel cell cost. As compared to other hydrogen energy sources, producing hydrogen is more costly, especially if this hydrogen needs to be converted to electricity. These two reasons are the reasons why the Philippines does not have a hydrogen plant yet. But in the future, where there is more demand for renewable energy, hydrogen energy will be much affordable with improved methods of processing and storage. And that will end the discussion of hydrogen energy alongside the whole discussion of alternative energy resources. Thank you for listening.